All right, guys, we are going to start off chapter 3 by copying some of these definitions into your notebook. So if you'll actually pause and go grab your textbook and copy down these 10 properties and theorems, definitions, if you'll copy those down, please, before we get started, that'll kind of save you some time as you go through the lesson. So this is 3.1. We're going to be talking about different pairs of lines and then what those lines create when they intersect, of course, would be angles. So we're going to be talking about different types of lines today. If you look at our Oh my goodness. If you look at our standards here today, it says apply the properties of parallel and perpendicular lines. We'll also be talking about a word called a transversal. And then down here a little bit, it says we're going to be talking about properties of angles as well, including corresponding angles, exterior, interior, vertical, complementary, supplementary, etc. So you've kind of heard some of these words before. We're going to get some further depth on some of these terms. So here's the first two. The first one says two lines are parallel lines if they do not intersect and are also coplanar. So if you have two lines, you guys know this already. If they don't touch, those are usually called parallel, but there's an extra piece to this definition. It says they don't intersect or they don't touch, and they are coplanar. So that part's going to be really important. If you look at the picture or the diagram off to the right-hand side, I would say line M is parallel to line N. So the little lines like that, the parallel lines, that's the symbol for parallel. So you can say M is parallel to N. And then if you look at the picture, the way to show it in the picture is these little arrows here. So if you see two little arrows, that means that those lines are parallel, and you can assume that they are parallel. The next definition says two lines are skew lines if they do not intersect and are not coplanar. So skew lines are also not going to intersect, but this time they are also not coplanar. So they're on different planes altogether. So if you look at them straight on, it looks like they're crossing, but if you turn to the side, you can see they're not on the same plane, and so they don't actually cross at all. If you look at the diagram, I would say line N, line M, sorry, is skew to line K. Because if you see M and K, they're not on the same plane. M is on plane T. And so, and then line K is straight up and down. It's intersecting the plane. It's not actually on the plane. And so you can see that those lines are actually never going to touch. All right, and so basically down here, this is what I was just saying. Lines M and N are parallel, which can be written like this. Lines M and K are skew. We also have such thing as a parallel plane. So down here it says planes T and U are parallel planes. So you can write it like that as well. And down there it says note lines K and N are intersecting lines. And there is a plane not shown that contains them. So if I drew a plane kind of like up and down this way, you can see that line K and line N are on that plane. So just kind of a fun fact there. It says that K and N, those lines are actually on a plane. You just can't see them. All right, so let's do some follow-up questions here. Here's an example. It says, think of each segment in the figure as part of a line. So for example, we have segment CB in the back. Think of that as line CB. So imagine these going on forever. It says, which line or lines or plane or planes in the figure fit the description? So the first one says, lines parallel to CD and containing point A. So first thing I would do when they ask you to compare it to line CD is go ahead and draw that line. Okay, so we have line CD, and we need a line that is parallel to this one, but also containing point A. And so of course, I'm hoping you're seeing that that would be line CB, or line BA, my goodness. You could also call that line AB. All right, next one. It says we want a line that is skew to CD. So again, here is CD. When a line that is skewed to CD and contains point A. So remember, skew means that they are not going to touch, but they are also on different planes. So I couldn't say AB this time because those are on the same plane. So skew to CD through point A would be right here. And that would be line AH. All right, next one. This time we want lines that are perpendicular to CD and containing point A. So remember, perpendicular means that they're going to intersect at a 90-degree angle or a right angle. So of course that would be right here, because if you notice in the diagram, we do have a 90-degree angle marked there. So I would say line AD. And then lastly, let me get rid of this. It says the planes that are parallel to plane EFG. So first of all, let me find an EFG. Here's EFG. So that plane would be the one on the bottom here. So we want a plane that is parallel to this plane containing point A. And so again, I'm hoping that you're seeing it. It's going to be the top one. That would be plane, let's say ABC. Now, of course, you can name the plane many different names. You could say anything using the letters A, B, C, and D. But remember, a plane only requires 3 letters. So I would say plane A, B, D, or D, A, B, or B, A, C, whatever. Any of those are good choices. All right, next, we have 2 postulates. The 3.1 postulate is called the parallel postulate. It says, if there is a line and a point not on the line, then there is exactly one line through that point that is parallel to the other line. So basically, they're just saying there's a line that exists that would make these parallel. Okay. Next one is very similar. It's a perpendicular postulate, but it's the same thing, just perpendicular this time. So it says if there is a line and a point not on the line, then there is a line that exists that goes through that point and also is perpendicular to the given line. All right. So moving on here, we have another example. It says use the diagram to identify the following. So first we're going to name a pair of parallel lines. Now, if you look at the diagram, there are some that kind of maybe look parallel, but remember you want to identify ones that are actually given as parallel. So it's super important to look for the ones that have the little arrows on them. So this little marker here and here, those indicate that they are parallel. So I would say line DM is parallel to line EF. Okay. You cannot say line BF and CE because, first of all, they're going to touch. If you notice, they're kind of, I don't know, at a diagonal a little bit, but also they don't have the arrows on them. So these little arrow markers are super important. That's how we know that something is parallel. All right, next we're going to name a pair of perpendicular lines. Remember, perpendicular, that means that it has a 90-degree or a right angle. So we're looking for 2 lines that have a perpendicular or a right angle. So I'm going to say line CE is perpendicular to line DM. There is another one, maybe you can see it. Line CE is also perpendicular to line EF. Now for line CE, this line right here, remember you can name that different names. You could say CE, you could also say DE, you could also say CD, right? Because that, since it's a line, it goes on forever anyway, and points C, D, and E are all 3 on the line. They're all collinear. So you could pick any of those two, you could pick any 2 out of those 3 letters to name that line. All right, next it says, is line FE, so here's FE, parallel to AC? Explain. So I would definitely say no. They appear to eventually intersect. However, I don't want to go on appearances, right? Also, let's say period. Also, they do not have the arrows indicating parallel lines. So although in the picture they don't even look like they're parallel, if they did give you those little arrows on there, you'd have to assume that they're parallel and that the diagram's just not a very good diagram. So if you saw these two little markers on here, you would definitely say that those are parallel. But in this case, they weren't written on there, and so you would say no, they are not parallel. All right. Next, we have another definition. This is called a transversal. A transversal is just a line that intersects two or more coplanar lines at different points. So basically, let's say I have these two lines here. The transversal would be a line that goes through both of these. So this right here, a lot of times they call it line T for transversal. That line would be called a transversal because it's going through two other lines. Now, when I do that, when I have a transversal, do you see how I'm getting all of these angles right here? Right? So I'm actually getting 8 different angles anytime you have a transversal, and all of those angles have different names. So that's what we're going to talk about next. This is actually going to be super important. We're going to use this a lot. So kind of dial in here and try to pay attention. All right, so on the left-hand side, we have angle 2 and angle 6. Those two angles that are marked right there, right here and right here, those are called corresponding. So corresponding angles are angles where they're on the same side of the transversal. So here's the transversal. Notice they're both on the same side of the transversal, but there is one interior and one exterior. All right, on the next one, we have alternate interior. They're called alternate interior because they are inside of the two lines, so inside or interior of the two lines, but they are on alternating sides of the transversal. So one's on the left side, one's on the right side, but they're both interior of the two other lines. So that's alternate interior. All right, next we have alternate exterior. You can kind of imagine what this one would be on alternating sides of the transversal again, but this time they are not interior, but outside or exterior of the two lines that are given. That's alternate exterior. And then the very last one is consecutive interior. Remember the word consecutive? Like if you think back to maybe even where you've heard that in just real world, consecutive means like one after another or one following the next. So consecutive interior means that they're on the same side of the transversal, but that they are also interior. You'll see in all of my notes when I talk about consecutive interior, I always circle them because they're the only ones that you can circle without touching any of the lines. So notice here, I can't circle those without touching the lines. So consecutive interior, these are going to be the ones that actually stand out later on in the chapter. You'll kind of see these are different than other ones. So pay attention to the fact that they can be circled and you're not going through any of the lines. That's how I remember it. Okay, so we're going to just practice using these new vocab terms. So first we're going to look at corresponding. So if you look back in your notes, corresponding were the ones that were on, well here, I'll just go back. Were on the same side of the transversal, but one interior and one exterior. So it looks like this. So if you look at the picture, I would say angle 1 is corresponding with what? That would be angle 5. Now there are more, so let's try a few more. Could I do angle 2 this time? Angle 2 would go with angle 6. But there are more. What if I started with angle 8? What would be corresponding with angle 8? That would be angle 4. And then of course there is another. What instead of 8, what if I did 7? Then I would have to do 3. So angle 7 and angle 3. All right, let's try some more. Next, we have alternate interior. So remember, alternating sides of the transversal. That would be like there and there. So they're interior, inside, but on opposite sides of the transversal. So that would be like 4 and 6. But also, what else? Angle 3 and 5. All right. Moving right along, we have alternate exterior, so still alternating sides, but this time we have one outside and another outside. So alternate exterior would be like if I started with angle 1, that would go with angle 7. Another set, if we had angle 2 this time, oops, angle 2 would go with what? That would be angle 8. Very good. All right, last one is consecutive interior, meaning consecutive means one after another, but also interior. So that means they're going to be on the same side of the transversal and both inside. All right, so remember, those are the ones I said were special. Those are the ones we can circle without crossing any lines. So 3 and 6, and then the last one, of course, would be angles 4 and 5. All right, so that is actually it for today. Here is the standards that we were supposed to address. So let's highlight what we learned today in yellow and highlight what we already knew in blue. So I would assume you already knew some properties of parallel and perpendicular. What else? We didn't know transversal. We know complementary, we know supplementary, we know vertical. Some things we learned today, I would say we learned properties of angles formed by a transversal. Properties of angles including corresponding, exterior, and interior. I think those are all new. So just to kind of bring light to what we've learned today. All right, so here is your assignment. Make sure you check Canvas to ensure that you've done what you're supposed to be doing for today. I hope you had a great day, and I will see you guys very soon.